Good afternoon. I'm Dr. Febina, working as Assistant Professor in Department of Food Science and Nutrition, Areca College, Tirunelveli. It is in Tamil Nadu. The title of today's presentation is In Silico Identification of Potential Inhibitors from Areca catechu against main protease of SARS coronavirus 2. You all know that COVID-19 is caused by novel SARS coronavirus 2. It is a global public health emergency infecting many people all around the world. Nature always acted as a rewarding treasure for novel therapeutics. Numerous studies have stated the potential of plant products on the wide variety of biological activities. In my study, I have selected Areca catechu plant, which is a palm, belongs to the family Arecaceae. It is a well-known plant and it is being used traditionally by various people all around the world. The objective of my study was to assess the therapeutic potential of bioactive compounds found in Areca catechu as potential inhibitors of main protease of COVID-19. The protease I have used in my study is 6LU7, 6VXX, 6Y2E, 6Y2F, 6Y2G, 6YB7. These are the structures of protease which I have selected in my study. 16 ligands were selected. The ligands were taken from Dr. Duke's phytochemical database. The ligands were arecaine, arecolidin, arecoline, beta-citrocerol, capric acid, catechu, diosgenin, gallic acid, guanosine, homoarecoline, guacoline, cryptogenin, linolenic acid, myristic acid, niacin, and oleic acid. The first step in my study was to select the protein and ligand. The structure of protein was downloaded from Protein Data Bank, and the structure of ligand was taken from PubChem. The ligand were checked for Lipinski rule of 5. The energy was minimized using Avogadro. The protein, the .pdbqt file and the grid file was generated using Pyrex software, and it uses Autodoc Vina. The molecular interaction between protein and the ligand was visualized using Discovery Studio. And finally, pharmacokinetics and drug likeness property was studied. Table 1 shows the molecular properties of the ligand. All the 16 compounds, they obeyed the rule, Lipinski rule of 5. So all the 16 compounds have selected for the study. This is the result for the molecular docking analysis of bioactive molecules from Areca catechu against main protease. Here, out of the 16 compounds evaluated, the binding energy is lesser than the upper threshold, that is -6 kilocalories per mole, were generally regarded as a cutoff in ligand binding studies, according to Mega and her colleagues in 2020. So only the value which is either -6 or above -6 was shown here. So figure 1 to 6, it shows the three-dimensional visualization of docking analysis of the main protease with ligands of Areca catechu. This is the result of the pharmacokinetic study of the molecules. All the compounds have good gastrointestinal absorption, and some have the capacity to pass through blood-brain barrier. Table 4 shows the drug likeness prediction. All the compounds have obeyed Lipinski and Weber rule, and some have 1 or 2 violation in case of gauche. This figure shows the bioavailability radar. The pink area represented the optimal range for each properties like lipophilicity, size, polarity, flexibility, insaturation, insolubility. So almost all the compound, they are within the optimal range, and some have some problem with insaturation and flexibility. All the compounds which I've selected in the study have some kind of interaction between the main protease of corona and the ligand, but beta-citrocerol, catechin, diosgenin, gallic acid, cryptogenin appear to have the best potential to act as COVID-19 main protease inhibitors. However, further research is necessary to investigate their potential medicinal use in vitro and in vivo condition. These are the references. Thank you. This is my poster. Thank you. Thank you for listening to my research work.